Hey everyone, this is graphing absolute value functions using transformations. I have added some extra things to the worksheet that will be available on Blackboard, but I will also have this notes copy available if you choose to use the computer to complete your worksheet, and then you can just continue working on this same one that I have already included graphs for. Okay, so we are going to graph absolute value functions. So let's take a look at the absolute value of x, our function f of x equals absolute value of x. So we take each of our x values and we take its absolute value. Our absolute value just represents the distance from the origin. So then we have the absolute value of -2 is just 2, and the absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1, and absolute value of 2 is 2. So it just makes everything positive. So then whenever I graph these, I have the point -2, 2, -1, 1, 0, 0, 1, 1, and then 2, 2. It makes this V shape. And this is what we call the parent function for absolute value. This is just the plain function. There's no adding or subtracting or multiplying. It's just our plain absolute value function. That's called our parent function. So this is where we're going to be starting whenever we use transformations, just like we've done in the previous two worksheets and notes. We're going to use these as our starting points, and we're going to apply the transformation. So I'm going to do 4 examples with you. And again, on these graphs, I've already included the parent points just so I don't have to scroll back and forth. But here we have the absolute value of x minus 2 and then plus 3. So these absolute value symbols work in the same way as whenever we had f of x minus 2 plus 3. So if f of x is the absolute value of x, then f of x equals absolute value of x minus 2 plus 3. We'll do the same transformations as this, which here this would have meant we've gone to the right 2 and then up 3. Well, that's what we're going to do here. This means we're going to go to the right 2, and then this means we're going to go up 3. So we're going to go right 2 and then up 3. So let's do that with each of our points. Right 2, up 1, 2, 3. Up, let's see, to the right 2, up 1, 2, 3. To the right 2, up 1, 2, 3. To the right 2, up 1, 2, 3. And to the right 2, up 1, 2, 3. So you can see that it still makes the same V shape, and it hasn't changed its shape, it's just changed its location. And where its vertex, this bottom point where the V connects here, its vertex has moved to the right 2 and up 3. Let's take a look at another example. So here we have -2 absolute value of x minus 5. It's -2 in the front. It's out of whenever we would call the parentheses, but now we have the absolute value symbol. So it's away from the x, so that means the negative means we're going to multiply the y values by -1, which is going to reflect over the x-axis, reflect over x-axis. We're going to multiply the y values by 2, so that means that we're going to do a vertical, because we're using the y values, stretch, because we're making them bigger, by 2. And then this minus 5 means we're going to go down 5. So remember, we're still doing the same order of transformations as we've done before. We look for left and right, then we look for multiplying the x, then we look for multiplying the y, and then we move up and down. Okay, so each of these points we're going to reflect over the x-axis, multiply the y value by 2, and then move down 5. 1, 2, 3, 4, 5. Okay, so then we have the y value of -1, so reflected over the x-axis. I'm sorry, y value of +1 reflected over the x-axis is -1, times 2, down 1, 2, 3, 4, 5. Then we take this next point. It has a y value of 0, so reflecting it over the x-axis won't move it. Multiplying it by 2 won't move it, but we can move it by going down 1, 2, 3, 4, 5. The next point, y value of 1, reflect over the x-axis, multiply it by 2, down 1, 2, 3, 4, 5. Then the last one, reflect over the x-axis, times 2, down 1, 2, 3, 4, 5. So you can see that because of the absolute value function, it's symmetrical once you know what one side is doing, you can figure out pretty easily what the other one is doing. And also because we multiplied by 2, notice if you look at the slope of each side, ignoring the fact if it's negative, but that we're going by 2 instead of just by 1 on the original one. And then the negative tells us it'll be opening down. Okay, let's look at a couple more examples together. On number 3, okay, so we always look for right and left first. So this plus 3 tells us that we're not going to move it to the right 3, we're going to move it to the left 3. And then this 1/2 is away from the x, it's in the front, so that means we're going to multiply the y values by 1/2. So that means we're going to do a vertical. Multiplying by 1/2 makes it smaller, so compression by, what are we multiplying by? 1/2. Okay, so those are the only 2 transformations that we have to do. We have to go to the left 3 and then multiply the y value by 1/2. So we're going to go to the left, 1, 2, 3, times 1/2 is just 1. Okay, to the left, 1, 2, 3, times 1/2. So we're going to have it right there in the middle. And then 0 move to the left, 1, 2, 3. 0 times 1/2 is still 0. To the left, 1, 2, 3. 1 times 1/2 is 1. And then to the left, 1, 2, 3. 2 times 1/2 is 1. Oops. 1 times 1/2 is 1/2. Sorry. Okay, so connect these points. Okay, so just looking at what this, we changed the y values, and so it made it wider, but if you imagine that we squished it from above and below, so it is having a vertical compression, it's being made shorter. Okay, one more example together, number 4. So we have negative 1/2 times x, absolute value of negative 1/2 times x. Okay, we don't move anything left or right, but we do have things being multiplied by the x. So the negative means we're multiplying the x values by a negative, which is going to reflect it across the y-axis. So reflect across y-axis. So that's the negative, and then the 1/2, remember we're not multiplying by 1/2, we're multiplying the x values by this reciprocal, because with the x it's always the opposite of what it looks like. So we're multiplying the x's by 2, so it's going to be a horizontal. We're multiplying the x to make them bigger, so that's a horizontal stretch by, and we're multiplying by 2. Okay, so starting with the same point on the left, if we reflect it across the y-axis and then multiply the x value by 2. The next one, reflect it across the y-axis. My x value is 1 times 2 is going to be 2. This 0 reflecting across the y-axis won't change anything, and multiplying 0 by 2 won't change anything, so that one stays there. This next one had an x value of 1 reflected across the y-axis, and then times 2 will give us negative 2. And then this x value of 2 reflected across the x-axis, y-axis, and then times 2 will give us negative 4. So our new graph is like that. So notice comparing number 3 and number 4 that they both look like they were just made that the arms just went further apart. But number 3 was a vertical compression because we were changing the y values, and so it squished it out wider. But number 4 was a horizontal stretch because we were pulling the x values out further apart. So even though just glancing at it, they are similar, there were different operations that we applied. One was vertical compression, the other was a horizontal stretch. Okay, so you're going to have 6 more problems to do on your own. Let me know if you have any questions, and I hope you're having a great day. Bye.